So yeah, the first big difference is the licensing. So CouchDB runs on the Apache 2 license, which is completely free to use, where MongoDB runs under the HPL 3 license, which is pretty much still free, but there are some issues, especially for enterprises who want to use that, because the terms of use basically include a copyleft. Now, I'm not a lawyer, you might not have heard of it, but it means something like if you develop something using the technology, you kind of give away the intellectual property of that written code using that technology. I might be a little bit wrong there, but that's roughly the explanation that the business has for not using it in certain circumstances. You can get a commercial license, but then you have to obviously pay MongoDB for the commercial license. Yeah. And then you still have to host it somewhere. In terms of hosting solutions, very recently IBM acquired Compose, which is kind of like MongoDB as a service. So you can set up a new MongoDB instance and they support all the scalability and the hosting and everything. And you just have a web API which you use to access it. Or you can just install it on-premise, obviously, as you probably do whenever you run a Meteor app. So another nice feature of CouchDB, which adds quite a lot of functionality and which makes the database a lot more powerful tool, is MapReduce. So who doesn't know MapReduce is pretty much a combination of mapping and a reduce function. It basically means that every document that you insert into the database, the key and the value, the key is the ID of the document and the value is the actual document. You push that, you can emit the document into a view or you can ignore the document. And you can also just extract certain information of your entire document. So just to give you an example, the example they use on Wikipedia is the word count example, where you basically have a document containing a text and this map function just splits the text into words and ingests each word with a counter of 1 into the database, into that view. Now, after mapping all the entries, there's a reduce function, which will now accumulate entries representing the same word, because so far we have each word multiple times, always with a counter of 1. And the reduce function would just push everything together, so you have a result of the word and the number of occurrences in that text. That's just a small example. There's a lot of other nice use cases out there, and just to give you a little bit of background, Google is actually using MapReduce for their search index. And yeah, the nice thing is that this MapReduce function is getting executed every single time you insert an element, and it can give you statistical views, aggregations, or extracting certain information from your database. So you can already see that this gives you a good foundation for an analytics tool that can display a dashboard with a lot of information aggregated. And the nice thing about it, it's reactive. It's reactive just as Meteor tries to be, but when it comes to aggregation in MongoDB, for instance, they are not reactive. I mean, you can do aggregation in MongoDB and Meteor, but you can only do it on the server side. And yeah, it's not reactive. You execute it once, you get a result back, and if you want an update, you have to execute the aggregate function again. So the result of that is not a proper cursor, where the result of a view, which is the result of a MapReduce function, is reactive, and it does have a cursor. Additionally, you also have attachment support in CouchDB, which I mean, you can put attachments into MongoDB as well. You can just base64 encode it and store it. But then you will always have issues handling the data because the data and the files, the attachments, are combined in one document record. So you have to subscribe to different subsets and decide which fields to return. If you want to display items in a list item, you might not need all the attachments, and you don't want to download them every single time in a subscription. So having attachments as a separate entity, they're still connected to the document, but you have to request them specifically, can save you a lot of network traffic. Now, you already saw the logo probably at the beginning, or maybe not. So Cloudant, quick introduction, is basically CouchDB plus BigCouch. BigCouch, before I prepared the presentation, I didn't actually know what BigCouch was, never heard of it. It's an attempt to build a scalable or a CouchDB cluster which can solve big data problems and hence the name, Big Couch. And so Cloudant basically offers you that. It offers you scalability and big data features as well as all the existing CouchDB functionality and a MongoDB compatible query language. And this is very important because handling CouchDB documents is always a bit cumbersome. You have to create views pretty much for everything. So even if you just want to retrieve a document by ID, you would have to normally create an index for that and then be able to retrieve the document. And don't get me started on custom queries when you want to query by fields. All that would require indexes and views. So, and additionally, Cloudant is cloud-based. It's pretty much the same thing as what Compose should be for Mongo in the future. Cloudant is already for CouchDB, so it's a cloudified version of CouchDB with some extra features. And since it's cloud-based, you don't have to scale it, it scales automatically. Now, looking at the current development, so at the moment we're here where CouchDB is at version 1.6. Now, the problem is right now this Mongo-compatible query language is not part of CouchDB. But, and the same goes for the clustering and the big data stuff. But they're currently working in CouchDB 2.0, and that will basically include the clustering, the big data, and the query languages from Cloudant, and they feed that back into this community version of CouchDB. Now, I didn't put any release dates in there simply because I couldn't find any. So the development team doesn't seem to be too eager to put themselves some deadlines there. And I also saw that there was not too much activity in terms of development progress. So you can just see by the last updates a couple of months ago, that usually means that no one currently has time to actively work on it. So far, just to come back quickly to Couch 2.0, there is a development version that you can use. So, and put yourself into the role of a developer who needs to develop some software using the CouchDB driver. For production use, you might use Cloudant or some Cloudant as the storage solution, but what do you do in your local development system? You don't always want to access a remote database. Additionally, you would have to pay for it. So you can install a local version of CouchDB 2.0. So there is a fairly stable development version which already has all the features in there. But of course, since it's really, really early alpha, you can't really rely on it in production. So getting into the details, so there's a guy from IBM India who started writing this driver, Cloudant CouchDB, and it basically replaces your typical Mongo collection with a Couch database. In Mongo, you have the concept of a collection. That is not the case in CouchDB. In CouchDB, you usually handle it with multiple databases, or you use a field to differentiate your documents, usually something like CDB type or so, and then it tells you which type of document it is. But this approach uses basically multiple databases, and they're generated or created in Cloudant or in CouchDB as they're required. So if you declare a new CouchDB database, the background, the driver makes sure that a database exists and then you have access to it. Now, in terms of functionality, so the driver is still in a very, very early stage. It's all still an alpha driver. We got basic query support, so I played around a little bit with it, and so far the use case that we tested most was basically just inserting items and querying items with different query parameters or dynamic queries. But we don't have any proper test suite, and I found a few issues when updating documents. So there seems to be an issue with how CouchDB handles revisions. So it seems like when you update, you create a new revision of that document, and so your update statement kind of should include all the existing fields as well. So we still have to review the driver there a little bit if that maybe should do that. So the driver behaves in the same way as it would in MongoDB. So the Vue MapReduce support is still pending, but in theory it's the same as querying a document. Because from an API perspective, the difference is very, very little, and it's just a different URL that is queried. But the result is still the same, so you can still retrieve your cursor in that way. And we hope we get that in the next couple of weeks. missing. Yeah. And this last feature, the fuse, the reactive fuse, that's pretty much what I'm looking for most of, because it really opens a new category of applications that you can build, which are those analytic applications. Imagine you have a dashboard which just shows you a live view of what's going on, which aggregates data from everywhere. But instead of basically feeding all the data into that reactive dashboard or using some boring timed update interval, you can just have a live view with that. And that's where I think it comes really into place. A little bit of code. So this is a model declaration basically in the shared code base accessible from the client and the server. And it looks fairly similar to how you would declare a collection in MongoDB. Instead, you just use CouchDB database, you give it a name, and you give it a variable name to access it. And additionally here, we're going to probably rework that a little bit and offer an API for that. Currently, you have to execute this code on the server, ensure that the indexes are created for all the parameters that you want to query. So if I have a query in the template helper, for instance, which uses a find query with some custom parameters, I have to declare them here as well. Otherwise, it won't find anything. So that's what I meant earlier when I talked about the need for indexes and views in CouchDB, which makes it a little bit more cumbersome to access. And if you think about it, if you have an app that defines a dynamic data structure, then you probably couldn't use CouchDB for that, simply because you wouldn't know what the dynamic fields are that you're going to query. Okay, what about accounts? So there's a fair bit of account packages out there which offer you all kind of authentication, and usually you would like to use that. Now, there is a little bit of development going on in the Meteor HQ as well. So they're currently trying to make the accounts base module a little bit more generic. So right now they have this hard-coded MongoDB client implementation, and now they're just declaring an interface, and then you need an additional package which defines the implementation for the client. And so we already created this account space CouchDB, which basically provides the implementation for account space. And then you also get account space accounts password CouchDB, which is basically accounts password plus a few extra functions. I have to check with the developer from India why he created a new plugin for that, but right now this is how it works. It's not 100% stable, but that's also because the Meteor hasn't released those new packages. They're still in development state, and basically what you have to do is import those custom packages, not just via Atmosphere, but you have to actually put the code into a packages subfolder in your app. What I expect in the future is additional packages coming from Meteor directly, account-based MongoDB, which is going to be the standard package, and account-based Postgres, which they're working on. Although I read yesterday in some forum posts that two developers who actively worked on the Postgres drivers just recently left Meteor development group, and now it's kind of uncertain how quick Postgres will actually come, but maybe you guys have more information on that. So anyway, this is the Git repository, and basically how to use it. You just clone the repository and put the packages folder into your app folder on the root level, and then in your Meteor packages, you just have to follow this order, exactly this order: accounts password CouchDB and accounts password. Only then the dependencies are correctly injected. So that is actually the first time I found that the order in the packages list makes a difference. And I hope I get some information back on this. So a colleague went to San Francisco recently and asked him to talk to the Meteor people about this, where they need to be more generic and provide interfaces. But with the current dependency manager, it's getting hard to provide interface and implementation packages and load them in the correct order. So, but they probably have thought about that already. So I just hope that at some point I can share what they came up with. And yeah, and then so you pretty much put those two packages at the beginning, and then you put all your other packages in whatever order you want to. Some more code for attachments. I have to avoid using the red color here. So I used Meteor Hex Picker here. I tried it this afternoon with Iron Router, but somehow I wouldn't pick up the server route. So I'll provide an example with Iron Router later on, and also in the documentation of the driver. So basically, you could define a route on the server like this, where you have download/document/document ID/file name, and then you just execute DB entries, which is our CouchDB database, and you pipe the attachment to the response, which is provided here. And in Iron Router, you can do pretty much the same thing. You just pipe it through to the response object that you retrieve from the router object. Additionally, we have functions like get attachments as buffer and insert attachment and remove attachment. Now, these functions are only accessible on the server side. So that is one restriction, and I'm thinking about, I need to probably document it properly so people actually know how to use attachments correctly. And yeah. So yeah, you have options to retrieve, read the data, insert data, remove data, and piping is just an additional option that you could also implement yourself by just piping the buffer. Oh yeah, and then I'll call an Ether. I'll get to that later. Let's quickly show something. So I'll build a little Cloudant test here, and so I'll put an attachment up there. So basically, I just choose a file to upload. And just update this again. And then now it creates an entry in CouchDB, and it also uploads the attachment. That's going to take a little bit because the database is currently hosted in the US, and yeah, network speed is not that great. But pretty much here I read the attachment from the database. This is the document ID, IIRF, whatever. And this is how the document looks in CouchDB. So you have some metadata which I added there. So those are my custom fields. I could put anything in there, like customer number or some other meaningful names, description, whatever. And then it has this attachment field here, which basically contains my file. And I can have multiple attachments per document. And whenever I read the document, basically all I get is this meta description. Here you see there's no data here. It just tells me how big the data is and and the content type. But to actually retrieve the attachment, I have to execute a separate function, which basically means the data that has to go through the wire is very, very, very small. And yeah, and this attachment here, the Fitbit all thing, basically you can access in Cloudant as well. That's basically the admin interface for Cloudant, and that's it. Just all of this here. Yeah. And
So Peter, sorry to interrupt.
mm-hmm.
That image you showed us, that's a screenshot, is it? So that's what you've got uploaded.
Sorry. Oh, you mean the attachment here?
Fitbit one.
So yeah. So that's an image. That's an image. I just.
Okay.
Oh yeah, it's a screenshot. Yeah, exactly. Yeah. Give me a second. I think I have a little bit more time. I can quickly show you the code used to create this new attachment. So basically, probably can't read that. Give me a sec. Where is it? Does anyone see it? There we go. Yep. Yeah. So here I basically create my file reader, and here I execute reader's data URL, which basically gives me an MD5 encoded string. And then once the reader finished loading, I just create my new item, which is going to be my new document. So this combines creating the new document and attaching the attachment. So I basically create my meta information here, and then I call Meteor method on the server, which creates the research document and provide this new item and the actual data. So this is the metadata, and this is the actual base64 encoded string. And here I just create my document, and which is the metadata, and then I attach my document with the actual data base64 encoded. And since we're already here, I can quickly go into the prototype. Pretty much what it does, it removes any encoding or content type declaration in front of the base64 encoded string, because I saw that when you load it with the file reader like that, it has this the content type and then colon base64 semicolon and then the actual data, and this is just to split it up, and then we just use the raw collection, the raw database driver, which is an NPM module, to attach the file. Yeah, right. And I mentioned that before. I got a little Easter egg, so something I stumbled across yesterday. It's actually a GitHub page which contains tons of tutorials and examples for all different kind of patterns. So I looked through it. A couple of things are very useful there. So whenever you have some time or bored, just have a look at this one.